So, okay. I'm going to preface it by saying that this is likely not going to come in your A-levels because it's not in the syllabus. So, but some schools have got this in their notes, so I'm just going to go through anyway. So this is y cube. Okay, meaning they're likely to test you in promos or whatnot. Now, what is first principle? First principle just means that we start with the axioms, meaning we definition. By definition, f prime x is given by this function here. So if you don't understand what's going on here, I'll just try and explain here. So what it goes is this. If I've got the curve like that, okay, like that, this is y equals x cubed. Okay. What happens is I'm gonna pick any x value lah. I'm gonna pick any x value. So any x value here, just let it be x. This is x. Okay, simple, right? So this y will correspond to fx lah, because this is fx lah. Okay, so if say is x, this will be fx. Okay, that's pretty okay. Not an issue, right? Then, right, I'm going to take another point. Now, this point here, I'm going to just add some form of delta x to it. Okay, so it looks like that. Yeah, you form this as like, this would be x plus delta x. So, this delta x will be a function of x plus delta x, like that. Okay, so it's like a... Okay, just follow me very carefully, This part here, what it means is this. This point here is x plus delta x, comma, fx plus delta x, the coordinates. This coordinates here is x, comma, fx. Is that right? So, the y coordinates, you just sub x inside, this is the y coordinate. Then if this is x plus delta x, this will be fx delta x. So these are 2 points here. Okay. Now, why is this important? Because what's going on here is I essentially just going to draw this line here. So here to here, like that. Okay. Like that. So this line here, this will be my gradient between the 2 points. It's gradient between the 2 points. Okay. So the gradient between the point 1 and point 2. Okay, this gradient between the point 1 and point 2 will be fx plus delta x. Actually, I don't really know which one comes first, but it doesn't matter. Minus x. Okay, so meaning this is actually just y1 minus y2 over x1 minus x2 just like that. Okay, it can be the other way around but yeah. So you see this one here, this is actually the gradient. So this is the first thing you must understand here. This is this. Okay, then we get this gradient MAB will be delta x minus fx over, like that. This is how it's being derived. Okay, now then what next? What next is I just make delta a very small value. Okay, so then it will become the angle there. Okay, so let me just illustrate this on Desmos. Desmos is our best friend. So let me just draw it out for you. So y equals to x squared, x cubed, right? Then if let me just put this as fx. Okay, easier. So let's say if I have delta, I'm not sure what's delta, I'll just let d be a value. Okay, maybe I just put x a plus fa. Okay, so I'm just gonna put this here. Then I'm gonna put the same value here, which means I'm gonna put d here. D here. Okay, I put a d here. So is this d too big? Yeah, it's too big. Okay, good job. So there you go. I got these 2 points here, right? So I know that this is a. It doesn't matter where is it at. So I'm gonna just put this out. Okay. Now what happens is, right, when we want to find the gradient at this point here, which is a point here, what we do is we just put d as a very, very small value. Okay, so we just decrease it. So if I can, you form a line between these 2 points here, right? You realize that as you decrease it, the gradient will become actually the gradient at this point here. Okay, so that's the reason why we let delta be very, very small. So meaning this one slide down, b slide down to a. Okay, so when you want the gradient at b, so hence the gradient at b, right, will be when delta goes to 0. So hence this is very technical already. So dy dx f prime x, meaning we limit delta x to 0, very, very small. We slide b down to a. This is 0. Okay, so that's why it's like fx plus delta x minus fx. Okay, slide it down to 0. Then we just examine the limit lah. That's the thing. Okay, but you need to understand. Actually, you really need to understand all these things in order for you to understand this. This is nothing more than just a gradient formula. It's not given at MF26. So if your promo come out, you really need to understand it's a gradient of a straight line. It's just gradient formula. Okay, and then you just rewatch this video lah. Then you should understand. Okay, so how do we find? Okay, so right, we know that dy dx, right, is 3x squared. Okay, so when you want to use first principle, right, meaning you cannot even use power rule or anything. Okay, first principle, you cannot use power rule, power function. The reason why you need to use first principle is because the power function use first principle to derive. Then we form a general equation. That's why we can keep using it. Okay, if you want to use first principle, means you can't even use power function. You really need to derive from scratch. So the good thing about this is we know the final answer. Okay, so this part here, to derive this, right? Okay, right, so from first principle, just let fx equals to x cubed. Okay, so f prime x, right, from first principle, we know is limit delta x goes to 0, and then it's just an equation of gradient. So this will be just f x plus delta x, the first point there, minus fx over delta x. Okay, this one is a gradient formula lah. I already derived it for you here. You actually got that already. Then this part here is pretty okay. So we need the limit of delta to 0. This will be x plus sigma x cubed minus fx, which is actually x cubed lah. X. Now, because you're only doing I know it sounds, because it's only H2-Math, only in the sense that because the limit that they'll ask, right, usually won't be like very jialat kind of limit, because at university level or H3 or even further math, the limit question can really kill one. Like, limit is another topic, is another module in uni, so we can't really test you a lot. So in other words, we are just going to expand this and you're going to see how. This one here, if you remember how to do your binomial expansion here, 1 1 1 1 2 1, 1 3 3 1. Okay, very quickly you can tell that this one is actually just let me just put it out. Okay, so I repeat 1 1 1 1 2 1 1 3 3 1 1 1 3 3 1. This will be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Okay, it's just binomial expansion lah. This is like secondary school binomial expansion lah. So I'm not gonna go through it very in detail, but if you have problem with this, let me know. I'll let you know what to do with this. I'll give you the course on binomial. Okay, so it's just this. So I'm just gonna expand using secondary school. I'm not gonna do it one by one because don't want to waste too much time. Plus sigma x cubed. Oh, what did I x? Jialat. You see this? Pascal triangle is this one, Okay. Okay, I'm gonna pause here for a while. Then what you do is actually, of course, this will minus off this lah. This will minus off this. Okay. Then I'm just gonna simplify this. And I'll eventually will get 3x squared plus 3x plus sigma x squared. Am I doing okay? Maybe I'll just do this carefully. This is square. Then this will be there you go. So what's the point of this? Okay, this one, follow me carefully. When delta x goes to 0, this will become so small, this will be 0. Because 3x times 0, any number multiplied with 0 will be 0. Everyone knows that. This is 0. So in other words, you will get 3x squared. So this will be 3x squared. Okay, first principle. Meaning you cannot use power law, you need to use from the definition. So the definition is actually just a gradient formula. And then you just imagine, right, you slide down the b pointing down to a, that's the gradient at that point there. Okay, so that's how you show it from first principle. Meaning, you should appreciate what you did in your secondary school. You're taught how to do the whole thing here. Okay, what's the idea here? Secondary school, you're taught to do all these things down here very quickly, right? Skip all this step here, right? It's because you don't understand this portion here. There's a general form which we form out for power function based on the first principle. That's why you are not taught that. Because you imagine in secondary school, if we teach you this, right, you're going to be like, what's going on? Okay? So, be thankful of your power functions, any kind of formula you learn, because they skip so many steps. We can't teach this, we can't possibly teach this in secondary school. So that's the reason why. Okay. Okay, I hope this is not too overwhelming. Yes. Okay, I tell you what, can you pick one? This one I think is similar to the first one, so I think you can go back and try. If you can't get it, you let me know. I don't even know to try the part 4. I don't even know, like, part 4 looks difficult. Can try later. Or part 3. Let me see. Part 4. Can try part 4. Part 4 looks difficult. Any question asked, Please ask. Oh, actually part 4 quite okay, quite fun. Okay, we can try part 4. FX. Question asked. Question asked. Question asked. Say again? Where did the tree come from for part 1? Where did the tree come from part 1? Where's the tree? Like
is the second line. I mean, not really second line, but like the binomial theorem part.
This one, is it?
Yeah.
You expand it, no? Binomial theorem.
Oh, wait. Okay, I got it.
Can? Yeah, so you just ask, this one is binomial theorem vowel free. So when I expand it, it's like that. What you do is you just, okay, maybe I just go through this a bit. This is 1, 3, 3, 1. Based on this one, 1, 3, 3, 1. Okay. If you need a refresher course on binomial theorem, I think we did. I'm not sure whether is it here. We just recently did an article on binomial theorem. So you can go and this one. You can go and listen to the video solution, and then it's a very good comprehensive guide. So it's all Pascal triangle here. You just listen to the. I know you're probably not going to read all this, but the video solutions are there, so you can just go and have a look. Yeah. Any kind of Pascal triangle thing, binomial thing, right, is actually just pattern recognition. So as long as you can pattern recognize it, right, yeah, it's pretty okay.